Epistasis is a form of gene interaction in which one masks the phenotypic expression of another. So an epistatic gene is one that determines expression. The gene being masked is referred to as the regulated or hypostatic gene. Dominant epistasis occurs when a dominant allele of a gene masks the effects of a dominant allele of another gene. Recessive epistasis occurs when a recessive allele of a gene masks the effects of a dominant allele of another gene. Important epistasis ratios. Dominant epistasis has a ratio of 12:3:1. Recessive epistasis has a ratio of 9:3:4. Recessive allele at one locus masks the expression of both alleles, dominant and recessive, at another. Duplicate dominant epistasis has a ratio of 15:1. Dominant alleles at either locus mask the expression of both recessive alleles at both loci. Duplicate recessive epistasis has a ratio of 9:7. Recessive alleles at either loci mask expressions of both dominant alleles at both loci. And finally, no interaction epistasis has a ratio of 9:3:3:1. Here we have a chart listing all the interaction types and their ratios. First, we have the classical ratio with a 9:3:3:1. A dominant epistasis has a 12:3:1. Recessive epistasis has 9:3:4. Duplicate genes with cumulative effect has a 9:6:1. Duplicate dominant genes has 15:1. Duplicate recessive genes have a 9:7 ratio, and dominant and recessive interactions have a 13:3. Here is an example of recessive epistasis. There are three phenotypic colors: black, chocolate, and yellow, with the ratio of 9:3:4. Homozygous recessive, or the yellow gene, is the epistatic gene. How's epistasis related to diseases? One gene can mask or alter the effects of another and increase or decrease susceptibility. This, in turn, can make it very difficult to track the disease-causing gene and its relationship to others.
Alzheimer's disease, neurodegenerative disorder that causes memory loss and dementia. Increased risk for the disease has been associated with the gene apoprotein E4. However, having one or two copies doesn't mean the carrier will develop the disease.
Cancer mutations can arise from a multitude of different combinations in gene defects and interactions. One method used to determine unknown interactions: combinatorial RNAi screening used in cell cultures to make GI maps, used with genes involved in kinase signaling, chromatin regulation, and ricin susceptibility.
Other diseases epistasis is involved with include cardiovascular disease, cleft lip and palate, schizophrenia and other neurological disorders, autism, hypertension, sporadic breast cancer, bladder cancer, and other types of cancer as well. And these are only a few.
It has been confirmed that there are 27 different significant epistatic interactions using these methods: beta amyloid production, inflammation, oxidative stress, cholesterol, and more.
In a 2014 study using 849 invasive breast cancer samples, 67 alteration-causing genes were identified and used to create GI maps. Epistatic was defined as deviation from the expected phenotype of these combining genes, and the gene alterations were grouped as gain-of-function or loss-of-function mutations and then compared with patient survival time to determine its effect on it.